In this lecture, we're going to talk about config. Now, you may have noticed that we have a config YAML file here inside the regression model directory. As an exercise, just pause for a moment and think, why do you think we are using a YAML file here instead of a Python file? Go ahead and pause the video and come up with a few reasons why you think that might be a good idea. Welcome back. So you've had a bit of a think about why use YAML for config. I've just pulled up this article from Colm O'Connor, who's the author of Strict YAML, amongst quite a few other useful Python libraries. And he has this article on his site about some of the risks of using Python code for configuration. A good rule of thumb is that you want to limit the amount of power that your config files have. If you write them in Python, it'll be tempting to add small bits of Python code, and that can cause bugs. Config files in standard formats like YAML or INI or JSON can also be edited by developers who don't know Python, and it's quite an interesting discussion, so I'll link to this page and a few others where you can have some further reading if you'd like to learn more. For our purposes, in our project, we're using YAML, and what we've done is taken all those global constants that we had in our Jupyter notebooks and switched them into YAML format. Now, if you're not familiar with the YAML syntax, we have key, colon, and value, and then where we have the nested key and then another key, colon, value, this is going to be a dictionary, and where we have the indented hyphen syntax, this is going to be a list, and the indentation matters in YAML. So yeah, we've moved all our config over into the YAML format. Okay, then if we head over to the config directory, we have our core py file. A few things that are happening here. So we're using pathlib to define the location of files and directories that we're interested in using. You might be used to doing this with the OS library, but pathlib is the newer way to do this in Python. So we're defining the location here of our config YAML file. We can define our package root like so, and we also define things like where our datasets are and where the trained models are going to be. Datasets here corresponds to this dataset's directory, trained models corresponds to trained models here. Then we're using this Python library called Pydantic to define classes which represent our config. Now, Pydantic is an excellent library. It's for data validation and settings management using Python type annotation. So it really works with the existing features of Python. And what that ends up looking like is that we define classes which inherit from the Pydantic base model. And then within one of these Pydantic base model classes, we define class attributes and specify a type hint so that when we use this to load data, we can run validation against the expected type of each individual attribute. So this is really powerful because it means we don't have to learn a new sort of micro language for data parsing, schema validation. We can just use Pydantic and our existing knowledge of Python type hints. If you're not familiar with Python type hints, I'll link to some further reading in the lecture notes, but the syntax is where you have a variable, then you have a colon, and then you define the type. And so for our model config, what we're able to do is for all the different fields that we have, we can define where it's going to be a list of, in this case, a list of strings. In some cases, you can use sequence, which means it could be a list or a tuple, and we have different things defined as floats or dictionaries. So this gives us a really clear way to understand and potentially test our config. And we wrap two different sort of sub-configs here. So we have everything to do with our model and then everything to do with our package. So things like the package name and the location of the pipeline save file. These are not really the sort of data science concerns. These are more just the development concerns, right? So we're separating that out into app and model config, and then we wrap it in an overall config like so. And you can see that we're able to define not just primitives like strings, but we can also have the expected type be of a particular class. So app config is expected to be of type app config class. And then at the bottom we have three helper functions. So our config, which is what we're going to be importing in other modules, is defined through this create and validate config function, and this uses our fetch config from YAML function, which we have above here, and this will then use our sort of lowest level utility function to find the config file, right? So using these paths that we defined at the top of the file, config file path, there it is. It's going to open up our YAML file, check that the YAML file exists, and so long as it does, we will then attempt to load it using the strict YAML load function. So strict YAML load, like so. Strict YAML is a type-safe YAML parser that parses and validates a restricted subset of the YAML specification. So it's a great library for working with YAML that can help you avoid some of the hidden gotchas of YAML. So that's why we're using it here. I'll link to that in the lecture notes if you're interested to learn more. And once we've loaded in our YAML file, we then use the Python ** syntax to unpack the key value pairs here and pass them to app_config and model_config as keyword arguments to instantiate these classes. And that results in us having this config object, which we're going to be seeing all over our package in the upcoming lectures. So that's why we're sort of starting our journey through the package tour by looking at the config. A quick exercise to bring this config to life. If we switch over to our command prompt, we're here in the section 5 directory, and we run tox-e train. This is going to train our model and everything works as we expect. However, if we go into our model config and remove something that's expected, like we know that we need a reference variable and we expect it to be a string, so rather than removing it, which is a bit obvious, if we just subtly make a change, so change the type that's expected and then rerun the command, you can see that we're getting a validation error here because we are not getting an integer, which is what our config expects. It's a string. So this is how we protect ourselves from incorrect config, and it's possible to build loads of tests around this sort of thing. So this is a really powerful way to prevent introducing bugs into our model through config mistakes. Go ahead and play with the config in your own local versions of the repo.